Hello, my name is Mr. Wilke, and we're still learning statistics. So, again, data, lots of it, nothing about it, we don't know what it is, so let's find out. Oh, there we go, NBA salaries from 2019. So, you'll notice these look different than the ones we did last time. Well, the baseball player ones we did were from 2020. So if I'm going to compare two sports, basketball and baseball, I'm going to use 2019 because those were full season years and it'll just make more sense. So there we go. MLB salaries 2019, NBA salaries 2019. So we're looking at two distributions. No idea what the shape is. Do I know what the center is? We haven't really talked about center yet, so we'll talk about that today. Variability, which one looks more variable? Clearly the MLB salaries, right? It stretches from 229 to 64. This one stretches from 137 to 110. Way more variable than this one. But let's get a better look at it. So we're going to do what's called a stem plot. All right, so I'm just going to do a stem plot of NBA salaries, and then I will add to it the MLB salaries. So here, this is a little bit weird. Have you guys seen stem plots, or also called stem and leaf plots before? Basically what you do is you take the first number and then a whole bunch of the last numbers. This one, not very variable, so I would do it like this. And that's all I'm going to have. So what I'm going to do is I'm going to do this. Like that. So these are the stems. So basically it's going to be like this. You write your key. If I did (13/5) is 135 million. So looks like I'm starting here. I'm going to go 0 through 4, 5 through 9. 0 through 4, 5 through 9. So just follow along. 0, 5, 6, 7, 7, 8, 9, 1, 1, 2, 3, 4, 4, 5, 6, 0, 0, 0, 1, 1, 1, 1. Right, 1, 1, 1, 1, 1, 2, 3, 3, 3, 3. And 5, 7. So now, looking at this, can you tell me the shape? It looks kind of, we've got way more data on the right. It looks kind of skewed left, but this is kind of bimodal. Who knows? Okay, but there's definitely a little bit of a gap here. Okay, so that's a stem plot. Always make sure you have your key. We can put a title, NBA salaries 2019. Now, if I want to compare the NBA salaries to the MLB salaries, so I want to grab these. so I can see them. Okay, so if I want to compare these to those, it's going to help to have it all on one graph. So we're going to do what's called a back-to-back sim plot. Now, with these, I'm going to have to go from 6 to 22. So let's make it look like this, 6. Okay, and I'll fix that up at some point. All right, so the first thing I'm going to do is I'm going to put the NBA salaries over here. So just going off this way, 0, 5, 6, 7, 7, 8, 9, 1, 1, 2, 3, 4, 4, 5, 6. Routine would be 0, 0, 0. Now you'll notice you want to keep these lined up just like we did before with the dot plots. 2, 3, 3, 3, 3, and then 5, 7. Okay, now I can get rid of this. On this one, so 64, 72, 3, 5, 1, 3, 4, 4, 7, 1, 4, 8, 5, 3, 4, 6, 8, 57, 59, 161, 168, 172, 174, 178, 207, 220. Okay, now I can get rid of that. Rid of the 207, 221, 3, 9. Okay, so we can see the difference in the two distributions. We can see the variability here. We can see how non-variable this is, right? All of the basketball salaries are roughly the same. The baseball salaries way more spread out. Okay, so we're going to talk about now. Is this a histogram? Yes and no, right? I mean, it's a stem plot, right? Clearly it's a stem plot. We still need the key. So by 3 is 53 million. Going the same way. All right. Still need the key. It's got that. But what's the shape here? This one's kind of symmetric, right? It's still grouped in the middle. It's a wide peak. Got a couple outliers, maybe. We'll talk about outliers at some point, probably next week. But yeah, so do we see the differences? Good. Okay, now, the reason I said it's a histogram is we could theoretically do this, right? And make it a histogram. So a stem plot will give you, as long as everything's evenly spaced, the same shape as a histogram. Now, I think in class we talked about how to do these on your calculators, but to make sure. So I've got all these numbers plugged into my calculator. Remember, second stat plot takes you to, or second y equals takes you to your stat plot. My plot is on. I want to look at a histogram. Now, there's the histogram. It says X list L1 frequency L2. I don't have the frequency here, so I'm just going to do L1 and for some reason this is stuck. Let's see, L2, and then I'm going to hit oh, that's why it's giving me alpha. I don't want alpha. I want just a number. There it is. So I hit 1, enter, and then I hit graph, and it looks like that. What did I forget? Oh, that's right, I've got to hit zoom. So I hit zoom, and then 9. Zoom, 9, and there's my histogram. And once again, we can sort of see, oh yeah, that is skewed to the right. This is the first one. This is the baseball players, I believe. Let's look, make sure. Oh wait, no, yeah, it's baseball players. So if I did L2, and I wanted to do a histogram, it's second, y equals, instead of L1, we're going to hit L2, which is second, 2, and graph. Got to zoom again, zoom 9, and there we go. So this one again, it's got the peak. Over there, it's a little bit skewed to the left. Okay? Any questions on that? Now, let's talk about how to find the center. Okay? There are 3 measures of center. Okay. 3 measures of center. There's the mean, median, and mode. All right? You've probably learned these at some point, but let's go over them just in case. The average, middle, the one that appears the most often. Now, which is the best measure of center? It depends on what our data set is, okay? On these. Is it going to be more important to know the mode score? I mean, the mode for basketball salaries was 131 million. Does that really tell us anything though? Not really. The only time I would use mode for center is if, well, if I'm looking at this class, which is about 6 juniors and 24 seniors, well, 12th grade would be the mode, right? That's a better center. I mean, it would also be the median, but that doesn't really tell us anything. Okay, the average we wouldn't even bother with because it's what? Yeah, we don't average sophomore or seniors and juniors together. That doesn't make any sense. Okay, so on these, I might want to look at the average. I might want to look at the median. So let's get the formula. The mean. The mean we're going to write as x bar. Okay? X bar represents a sample mean, okay? So the mean is the sum of each individual x divided by n being the number of numbers in the data set. So I think there's 30 teams for both. So whether we're looking at MLB or NBA, n is 30. So we add up all of them and then divide by 30. If I'm looking for the median, count in from the ends until you meet in the middle. So looking here, start there. 1, 2, 3, 4, 5. Well, there's 30, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the median is going to be between 126 and 130. If there's two medians, do we remember what to do? That's right, you average them together. Good, so it's going to be 128 million. Over here, it's between 15 and 16 because there's 30, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's going to be between 135 and 143, so the median is 139. So baseball, the center, at least if we're using the median, is higher than the center of basketball. Now, what about the mean? Well, we can work that out easily on our calculators. There's a little trick that we do on a calculator that I will show you at some point, probably within the next couple days, and we'll be able to tell where the center is, okay? Now, here's something that classes sort of struggle with grasping the concept of, so let's talk about it and see if we can understand it. What is the best measure of center? Well, the best measure of center is the mean, okay? It's the average, it's the mean. However, if it's so skewed that the mean becomes meaningless, the best measure would be the median, all right? Really, if you're going to use the mean, you want to use the mean when it's symmetric. When it's symmetric, the mean will equal the median, okay? So always use the mean unless the mean is not equal to the median, in which case use the median. Now, somebody always asks, so I'll give you a second to think of the question. Yeah, there it is. Okay, why don't we just use the median? Well, because the mean is a better measure of center. Okay, so when you can use mean, you want to use mean, but when you can't, that's when you use median. I hope that makes sense. I know it doesn't. Okay, any other questions? All right, well, thank you for coming. Thanks to Warbringer for the t-shirt, and I will see you guys next time.